All right, you guys ready?
Yeah.
Boys, ready? All right, so once again, I want you guys to hang on to these pink sheets because they're very important. Okay, I'll use them on your test, but you need to make sure you know what's going on.
Wait, you said we can use this as a test?
So make sure you're writing down exactly what I write down. Don't skip around. Okay, so we're doing radical rules. Last time we did exponent rules. Okay, so now we actually have different radicals. I know last time our yellow sheet, it went in order from like top, bottom, top, bottom, top, bottom. Now we're going straight across. So make sure you're writing in the right space. Okay. All right, so first one is power over root. We've talked about this. That was our first one that we ever did. My power, if there is not a number there, it is understood to be what? 1, and my root is understood to be 2. Okay? If there's nothing there, that's what it is understood to be. Does anyone want highlighters? Okay, if you don't want highlighters, that's fine. But where I'm highlighting, you may want to like underline or circle or something so you know what's going on. Alright, so I have, let's say I have the square root of 3 to the power of 3. What is my big number that I'm going to write? 3. That's what's under my radical. What's my power? My power is 3. And my root is here. That is not there, but is understood to be 2. So you should have 3 and to the power of 3 over 2. Okay, that's my power over my root.
Yeah, I did this too.
It's understood to be there. There's nothing there, which assumes it's the square root. Okay. My next example. If I have the fourth root of 2 to the power of 2. What's my big number that I need to write? 2. My power is 2. And my root is 4. Whenever we have all numbers, I didn't mean to do that. Are you guys writing in pencil? Yeah. Alright. Erase this 2 and put X. So it should be X to the power of 2/4, which 2/4 can basically reduce to what? 1/2. Okay, so just like we did last class, we're going to go back and forth. Grab your packets. Alright, rational exponents rule, numbers 1 and 2. Ronaldo, what number is under my radical?
Under?
Yeah, what's under my radical? Yeah, that's my big number. That's what I'm focusing on. What's my power on 25? You guys got it? Okay. What's my power?
2. Oh, wait.
2, yeah. And my root is right there, it's 4. Your root is always inside your
So
radical.
the root's gonna be on the left.
Yep. Yep, your root is always on the inside. Your power is like an exponent. Put this into your calculator. What is 25 to the power of 2 over 4? You should get 5. All right, for my second equation, let's change this bottom half to be power over root. So on top I have 10. On the bottom, I'm going to change it to be a radical. What goes under the radical? 125. And what's my power? 1 and my root? All right, let's leave the top as it is. What is the cube root of 125? 5. And so 10 divided by 5, I'm just breaking this up bit by bit. You should get 2. If you wanted to grab your calculator and type in 125 to the power of 1/3, you would have still got 5. You don't have to change it into the radical. I was just showing you that that's an option. All right, it's where life gets real. Go back to your pink sheet. We're in the top middle, where it says radical addition. Top middle. All right. What this says is that our radicals, if we're adding, have to be the same. Okay? If we're adding, our radicals have to be the same. And then we'll take the numbers on the outside and we'll add those together as well. I like to compare it to a fraction. If I have 1/4 plus 1/3, my answer is not 1/7. Okay? Your denominator has to be the same. Same thing here. Your denominator has to be the same, or your radical has to be the same before you can add it. So let's say that we have 3 times root 2 plus 2 times root 2. Take a look at your radicals. Are they the same? Yep, they are. Your radicals are both the same. So your answer, your radical will be exactly what it was. Square root of 2.
Oh, so it doesn't change.
It does not change. It does not become square root of 4.
Just the number that's outside?
Mm-hmm.
Okay.
So the numbers on the outside, 3 plus 2 is 5. So my answer is 5 root 2. All right, example 2. Let's say that I have 2 to the 5th two times the fifth root of 7 plus 6 times the 5th root of 7. Okay? Do I have the same radical?
Yes.
Yes. This guy matches that guy, so I can write it again. It is important that you put your root in there. It's the 5th root of 7. What happens to my 2 and my 6? We add them together. So your answer is 8 times the 5th root of 7. Does that make sense? Okay. Let's go to our packet. Numbers 3 and 4. All right. Throw you a little curveball here. Are my radicals matching?
No.
No, they are not. So this goes back to what we already did in the past. We need to simplify this first radical. Okay? They're not matching. So if we have, let's just forget about that 5. The 4th root of 3x to the 5th power. Can my 3 possibly come out of this radical? No, it is not. There's no 4th root of 3. But I have 5 x's. I need how many groups to come out?
4.
I need a group of what? A
4.
group of 4. So this group of 4 can come out, right?
Yeah.
So this will reduce to x to the 4th root of 3, and what's left over? 1x. Do we see now that those two are now matching? Because I simplified it. Alright, so make sure you're writing exactly what I write. This 5 was already out in front, right? I'm also going to add an x because we had to simplify what was highlighted. So if I simplify what was highlighted, I have x to the 4th root of 3x. On the other side, I'm just going to rewrite what was already there. Now take a look at your radicals. Are they matching? Yes. Now that they are matching, we can go ahead and simplify. What's 5x plus x? No, that's times 6x. And then my radical is just going to stay the same. The 4th root of 3x. That is my answer. So on that one we had to combine what we already learned from last class. Make sure you're not just writing the answer, you're writing exactly what I'm writing. On number 4, are my radicals matching? No. Which one can I simplify? The 16. There is no cube root to 16, so I'm going to do the factor ladder. My smallest number to go into 16 is 2. I divide, I get 8. Smallest number is 2. I divide, I get 4. Smallest number is 2. I divide, I get 2. 2, 1. I need a group of how many numbers? 3. There's my group of 3. So when I rewrite this, I have 2 times the cube root of what's left over. 2. And then I'm just going to rewrite the first one that we just had. So now I have matching parentheses. Okay, now that they're matching, I'm good. My matching parentheses, I'm just going to copy over. And what's 2 plus 5?
7.
You should get 7. That is your answer. Any questions on 3 and 4? All right, radical subtraction is the same concept. It's just we're subtracting the numbers. We want our radicals to match, and once they match, I can subtract whatever's in front. Okay, so an example for you. If I have 3 times the square root of x minus 2 times the square root of x, my answer is going to be what? I have matching parentheses, I have matching radicals, so I don't have to simplify anything. What goes in front? What's 3 minus 2?
1.
1. Do we have to write that?
No, but
No. If you want to, go for it, but we don't have to. Okay? For adding and subtracting radicals, make sure that you have the same radical. All right, number 2. Okay, second example. Let's say that I have the cube root of 16 minus 4 times the cube root of 2. All right, look back at your packets. We just did this, okay? We just simplified the cube root of 16. What did we get? We got 2 times cube root of 2, right? We're going to save ourselves some time. We're going to write that again. 2 times the cube root of 2 minus 4 times the cube root of 2. I now have matching parentheses. Oh my gosh. If I say parentheses one more time.
Just stop the list.
Yeah, I will. We now have matching radicals. So that's the cube root of 2.
-2.
And then -2 goes out front because 2 minus 4 is -2. Okay? Let's do my problems here. I do not have matching radicals here. I need to fix something. So let's simplify. I also have to simplify 8. Okay? The smallest number to go into 8 is 2. We divide by 4. Your smallest number to go into 4 is 2. We divide, we get 2. Smallest number is 2. We divide, you get 1. I need a group of how many?
2.
So this will be 2 root 2, right?
Right.
We'll put it all together in a second. We also have to do a factor ladder for 50. That is not a perfect square. So 50 divided by 2 gives me 25. I divide by,
Okay.
oh, not 2.
5.
I divide by 5.
You get 4.
Now you get 5. Divide by 5, we get 1. I get a group of 2. So my answer here is 5 root 2. So here's what we have to do. There's already a -2 out front here, right? When I simplified the square root of 8, I got 2 times the square root of 2. If I simplify that, what do I get? What's -2 times 2?
-4.
So we should get -4 times the square root of 2. That's the first one. For the square root of 50, I got 5 root 2. There's nothing else to do with that. I can't do anything else with 5 root 2. Do I have matching radicals? Yes or no?
Yes.
Yes. So you guys see this process here. I know it's long, but we have to simplify our radicals. So we get square root of 2. What is -4 minus 5? -9. Not yet. All right. Remember, we cannot just subtract these. We have to simplify them first. I'm going to simplify the square root of 12. I need a group of 2. So this simplifies to 2 root 3. This other guy over here is not a perfect square, so we get 3, 9, 3, 3, 3, and 1. So my answer is 3 root 3. So all we have to do is basically subtract these two. What is 2 times root 3 minus 3 times root 3? I just simplified both of these. -1 times the square root of 3. Because your radicals have to be the same.
Are you
All right, you guys ready? Sonalda?
Yeah.
All right, here we go. All right, so when we are adding and subtracting radicals, Alex, it has to be the same radical, right? When we're multiplying, it does not. It does not have to be the same when we're multiplying. So if we have, oh man. Gotta recalibrate. Hold on a second.
I didn't.
I don't know why you guys are so low and snowball. Alright. So, whatever you have under the radical, you're just gonna multiply together. Whatever you have on the outside of the radical, you're gonna multiply together. Alright, here's an example. Let's say I have the fourth root of 2 times the fourth root of 8. Because we are multiplying everything that are alike together, whatever is under my radical gets multiplied. What's 2 times 8? Guys.
16.
Thank you. It's a little scary. Alright, grab your calculators. Type in the fourth root of 16.
4.
If you forgot how to do that,
Would it be 2?
yeah, it would be 2.
Wow.
We have to plug in a fourth root. So you type the number 4, you go to math, hit the number 5, it plugs it in for you. Your answer here is 2. Alright, let's do the square root of 3 times the square root of 6. What do we get here? What's the square root? What's 3 times 6?
9. So now I'm kidding. 12. No, without it, 18.
18. My goodness.
Yo, why am I the only one that's saying, come on?
Alright, so the square root of 18, I'm going to simplify that. So I'm going to do my factor ladder. If you guys wanted to like make a cheat sheet of some of these like common ones that we have, I'm okay with that.
We use it himself.
I mean, you can put it on the back of these papers. I mean, we've had the square root of 18 a lot. We've had the square root of 27. Like if you see the ones that we've had a lot. Alright, we get 3 root 2. That is my answer. We just multiplied it together, then we simplified it.
Why are you spraying on your spread?
We got a while. Alright, number 7. Okay, everyone focus for this one. I'm going to multiply everything that is alike together. So negative 4 times 2 gives me what?
Okay.
Negative 8. My x can stay on the outside, right? I'm going to make one big radical, and we're going to multiply things that are matching. So what is 3 times 4?
12.
12. Good. Then I have x times x. No. We just worked on this. X to the first times x to the first. Add your exponents.
Sure.
You get x squared. Your y's, you have y squared times y to the first.
Y cubed.
Yep, y cubed. My z is all by itself, so it can stay z to the fourth. Makes sense? I know you think you're done, but you're not. Okay? I know. Alright, let's see here. What we have to do is simplify everything inside the radical to make sure we're done. I know the square root of 12 can be reduced. If we do a factor ladder for the square root of 12, you should get 2 root 3, right? So what we're going to do is we're going to make another radical. Alright, on the outside, my negative 8 is already there. My x is already there. What happens to this group of 2? Does it go on the inside or outside? Outside. What happens to my 3? It goes on the inside. Good. All I did so far was just rewrite my negative 8x and I simplified the square root of 12. What we did on the first day was simplify how many groups we would need. I have 2 x's. This is basically a square root, right? A group of 2. There are how many groups?
One.
There's 1 group, so you bring that out. I have 3 y's. There's how many groups of 2? Everything else stays under the radical. My y by itself stays.
Z squared.
Good. I have 4 z's. So I have 2 groups,
I got some Z's.
and that is z squared. I know this looks super long. It is. So if we clean this up, let's multiply what's on the outside. 8 or negative 8 times 2 will give me negative 16. What does this x and x make? X to the first times x to the first? Yep, so x squared is on the outside. My y is good. My z squared is good.
Wait, so they stay outside?
Whatever's on the outside. Yep, all my pairs go to the outside.
Shut up.
Whatever's left over stays under the radical. That is my answer. So the difference between this first answer we got and the second one was that the first one is not simplified.
The first one will be wrong.
If it says to simplify, yes. You're not going to have too many of those, though.
Good.
All right, number 8, we're just multiplying everything together. What is negative 5 times negative 125? What is it?
625.
What's the square root of 625?
25.
25. Any questions? All right, let's look at this one. It's a little brighter. All right, so radical division. For radical division, if it is, well, these are kind of interchangeable. If we have, guys, are you with me? We basically want to separate them into 2. Okay? When it's easiest to do so. Sometimes it's easiest to leave it as a large fraction and then divide, but you'll be able to tell which ones are like that. Alright, so your example. If I have the square root of 4 over 9, does 4 over 9 simplify evenly? No. Because it does not simplify evenly, I want to separate it like the square root of 4 and the square root of 9. I make them their own. What is the square root of 4? 2. What is the square root of 9?
3. Section.
That's not that bad. Wow. This is where it gets a little bit more complex. My second example. If I have x cubed divided by 100. If we have something like this, Ronaldo, pay attention. You're going to be confused. We absolutely will want to separate these 2 radicals. So I have the square root of x cubed divided by the square root of 100. All I did was just separate it. The square root of x cubed can be simplified. If I have 3 x's, how many do I need in a group?
3.
2.
No, you need 2.
2.
So how many groups of 2 do I have?
1.
And how many is left over? That's what's on top. What's the square root of 100? Huh? 10.
You wanna go Miss Kirk?
Yes. Any questions on this example? All right, take a look at number 9. Do we see how this number 9 is better if we make it all over 1? Because you have 6 over 48. Type in your calculator 6 over 48 and you get an even fraction. Math, enter, enter.
20.
Yeah, so I'm going to put this all under 1 because I can reduce it to be 1 over 8. Okay? The reason we do that is because I can separate it, the cube root of 1 divided by the cube root of 8. Actually, leave your answer like this. Once you get your fraction, you can leave it like that. The cube root of 1/8.
That's gonna be cool.
All right, number 10. Try your calculator. Does 343 divided by 27 give you an even fraction?
No.
Not even if you hit math and enter, right? All right. So this is one that we're going to want to separate. So I have the cube root of 343 x to the 5th divided by the cube root of 27 y to the 9th. I just separated them. In your calculator, what is the cube root of 343? We're doing what's on top. What's the cube root of 343?
7. Oh, the cube.
You should get 7. Then we have x to the 5th. So I have 5 x's. I need a group of how many?
3.
3. So how many groups come out?
1.
Then how many are left over?
2.
X squared. So we have 7x to the root of x squared on top.
1 day. I knew you were calling.
Keep track.
Guys, I'm losing patience. What's the cube root of 27?
9.
The cube root. You should get 3. And then I have 9 y's.
3.
Alright, so I need groups of 3. That's 1 group, that's 2 groups, that's 3 groups. So all of them come out. That is my answer. Alright, go back to your pink sheet. Rationalizing denominators. What this means is that we don't want a denominator or a radical in the denominator. This right here cannot happen. We don't like it. So what we have to do is we have to get rid of it.
It can either be
Nope.
both.
Let's say that I have 1 divided by the square root of 2. That's my problem. I don't like that I have the square root of 2 on the bottom. So I am going to multiply by my denominator, which is basically like multiplying by 1. On top, I have 1 times root 2. On the bottom, we have, what's the square root times, square root of 2 times square root of 2, which is square root of 4, right? Square root of 4 is 2. So, the little trick here is that whatever's on the bottom, you can just cross out your radicals and just keep your number. This number is okay to have because now I don't have my radical on the bottom. It moved to the top.
Oh, it can be in the bottom. That's it.
It can't be on the bottom. Alright, our second problem, let's say we have 1 divided by square root of 3. I'm going to multiply by what? Root 3. So on top, it just stays the same. I have 1 times root 3. On the bottom, what do I have? I have 3, because if we multiply that, root 3 times root 3 is root 9. Square root of 9 is 3. That's our little trick. We don't have to go through the whole thing. We can just cross those out and keep the number. They basically cancel each other out. Alright, your last two numbers. Let's change this d to an x. I don't know why. Let's do the square root of 2x. 2z just is too confusing. Alright, so I don't like the radical on the bottom. I'm going to multiply by my denominator. What do I have on top?
1, 2x.
No. If I just multiply straight across, what do I have? 4 times. I can't multiply this and this to be 8. Because one has a radical, one doesn't. So I have 4 times root 2. On the bottom, what do I have? 2x. Can I simplify this?
Yeah.
To be what?
Yeah.
This can simplify to 2. So my answer will be 2 root 2x divided by x. I just simplified that 4 and that 2. I cannot simplify anything that has a radical with something that does not have a radical. So I can't cancel out these two x's because the first x is under a radical, the second one is not. Okay, if you're going to simplify, it has to be outside the radical. All right, last one. Let's try this or all together. Let's see if it reduces evenly. What is 9 divided by 16? Do we get an even fraction or a clean fraction? We should not. Okay? So let's go ahead and separate this into 2. 9x squared divided by the square root of 16y. All I did so far was just separate them. Alright, on top, what's the square root of 9? 3. And then I have 2 x's, I need a group of 2, so how many groups come out? 1. Alright, that's the top. On the bottom, what's the square root of 4, or 16? 4. 4. And my y has to stay. Okay, because I don't have enough to bring it out. This cannot be my final answer because of the radical that's underneath. So I can multiply by what? What's on the bottom? 4 times root y, and then 4 times root y. Whenever we have a radical on the bottom, we just multiply by that denominator. So this is what matches. We don't like that guy. I multiply it by itself. We didn't like this guy. I multiplied by itself. Alright, let's clean this up. On the top, what is 3x plus 4? Huh? 3 times 4?
Oh, times 12.
12. My x can stay. My y can stay. On the bottom, what happens to, well, let's see. On the bottom, I have 4 times 4, which is
16.
16. What happens to my square root of y?
Goes away, but y stays.
So y stays.
That's your answer?
That's your answer, or you can simplify it to be 3x root y divided by 4y. Remember, you can only simplify what is outside of the radicals. Does that make sense?